who is a joint director at at BMTPC, and
National
NCCBM.
Council for Cement and Building Materials, NCCBM.
NCCBM, and he will be highlighting the importance of the chapter and use of the building materials. And so, as we know that building materials from foundation of every structures, and NBC and as a National Building Code gives us a unified framework to ensure that these materials are safe, durable, and appropriate for Indian conditions. So, objective of this chapter is very simple, but it is extremely important to ensure that any materials that is used in construction performs safely and reliably over its entire life. So, NBC as a code help us to standardize the material use across the country, so that regardless of where the project is located, quality and performance remain consistent. So now I will be inviting our expert who will be giving this lecture, Shri P.N. Ojha ji. Ojha sir, good
Thank
afternoon.
you. Thank you very much.
Over to you.
So, am I audible and visible both?
Yeah, sir, you're
And
very
my
well audible.
slide is visible?
Yeah, sir, your slide is also visible.
Okay. So, let us start. So, standardization on building materials. So, activities of BIS. So, everyone is knowing. So, I am not going to explain this activity of BIS and standardization process a little bit. And then I will start the cement, aggregate, concrete, then lime and gypsum a little bit, then reinforcing and pre-stressed steel, bricks, tiles, timber, stones, and other innovative materials. So building materials covers a numerous type of building materials, and so many standards are available. So I would like to cover everyone so that the participants can read on their own all those standards and can apply them in the real life situations. So with this background, activities of BIS, everyone can read it. This slide will be perhaps shared by the BIS to everyone. Okay, so I'm not going to read it. But yes, standard formulation is one of the major activities of BIS. And then BIS have a laboratory recognition scheme also, product certification also, compulsory registration scheme. Apart from this, foreign manufacturer certification, hallmarking, laboratory services, Indian standard sale, then consumers affairs activity and training services and information. All these activities are the part of BIS. So now comes where we would like to. So what is a standards? So any standard is, let's suppose a product is having some desirable property and some undesirable property. So those standards in terms of a quantitative value most of the time, or even if qualitative based on some colors and all that. So the desirable properties and desirable properties are listed and their values. Let's suppose if it is desirable property, then it should be more than that. And if it is undesirable property, then it should be less than that. In that terms, the standards identify and for a particular product, right, written down, and how those values will be determined, that will be determined in the laboratory. So that is called test method. And the standards of those property, so property of those products are called a specification. So standards are of two types basically. One is a specification and another is a test method. So this is the meaning of a standard, and when you are using it, then those specifications will have to meet, and to how it is meeting or not, the product will be tested as per a specified test method. So this is the meaning of a standard, and these specification and the test method is applicable in a standard form which is available to everyone at the same platform, and that's why it is being called a standard. Okay, so this is the meaning of a standard. To understand, one can read this language, but this is the meaning of standard in a practical term. Okay, so standardization should have transparency, openness, and impartiality and consensus. One can go through it, and then effectiveness and relevance, coherence, development, and dimension. And aims of a standardization is fitness for purpose, compatibility, interchangeability, variety control, safety, protection of the environment, and product protection. All these are the aims of a standardization. National standards benefit are technologies for product, for consumers, and for traders. So I'm not discussing all these things quickly. I am coming to the this is the Civil Engineering Divisional Council. Civil Engineering Divisional Council, if you will see, all the civil engineering committees comes under this Civil Engineering Divisional Council, CEDC, and yearly or twice in a year meeting happens, and in which area, which type of standards is needed. So all the experts from all the field of civil engineering sit together, have the meetings, and debated, and based on the consensus view, standardizations framework and future plans are made, and according to that, so it is at most body CDC which gives the suggestions, opinions, and in which area the standards are to be made. Okay, so these are the committees available in the Civil Engineering Divisional Council, right from CD2, 3, 4, 5, like that. So we have a number, and within this committee, we have a panel. Means, let's suppose as cement and concrete. So we have cement, then concrete. Concrete has various products like aggregate and all that. So for standards, let's suppose aggregate has specification, test method, and all that. So we have a panel for that who will deal with the aggregate. A panel is there who deals with the IS 456. A panel is there who deals with the chemical admixtures, like that. So every committee has some panel, and panel can formulate a working group for a particular standards to be drafted or to be revised, like that. So a standard must be needed, implementable, timely, acceptable, and it should be current. So any building material has some properties which is we can call it physical or mechanical property. And physical and mechanical properties is the performance in the civil engineering structure. And for those performance, let's suppose a cement strength or fineness or anything, these are the mechanical or physical property, we can say. And the reason behind those physical properties is what are the chemical compositions. So we have standards. When we have standards, any standards, there are some physical property and their values and their test method, and there are some chemical properties and their values and their test method, how it will be determined. Some product should be durable in nature, so durability properties also. And the fourth type of properties is how it looks like, so general appearance. And then for testing those products, how the laboratory sample should be picked up for testing. Let's suppose a heap or 1,000 items are there. So how many items, how it will be picked from there for the testing, that is called sampling for conformity. And conformity means when it will be tested, it should meet the standard. This is called conformity. So sampling for conformity is also available in the product standard. Okay. So this is these are the basics a standard should have, particularly a specification standard. And a specification standard will mention the how it will be tested, what should be the procedure, that is the test method standard. So the raw material cement is manufactured. So raw material is mostly limestone, and the some additive can be added like laterite and all that. So material calcareous and argillaceous materials are added. But to remember it, limestone and other additives like clay, because the cement is manufactured by having chemical compositions of oxides, lime, alumina, silica, and iron. Lime means CaO, alumina means Al2O3, Fe2O3, and Al2O3. So this composition should have a material having these oxides, and for cement manufacturing, these values are there. So combined together, those materials should have those values, and then it is ground together, means a powder-like material, and then it is heated in a kiln at 1450 degrees centigrade. Then again, though that powder materials becomes a nodule, a spherical balls like material. Those are called clinker. And when that clinker is ground along with the gypsum, that is called cement. And when that clinker and gypsum is ground together, that is called OPC, ordinary Portland cement. When some part of fly ash is added as per specification of specification up to 35%, more than 15%, up to 35%, then it is PPC. When ground granule, blast furnace slag is added, then it is called slag cement, Portland slag cement, like that. When slag and fly ash is added together as per specification again, then it is called composite cement. So in this way, we manufacture the different variety of cement. And as I said, the cement should perform. So we have certain physical property like consistency. We can call it consistency, means the quantity of water to be added by in terms of percentage. Then setting time, initial setting time, final setting time, then fineness, plain fineness, then strength, 3 days, 7 days, 28 days strength. And cement should not be adverse to the soundness. So it should be a sound. So soundness test, leach Tellier soundness and autoclave soundness, and their values are there in the specification, like that. So all these are the physical property and chemical property. LOI, what should be LOI, what should be lime, what should be silica, what should be this, and in terms of sometimes ratio. So these are the chemical properties that is also there in the standard of cement, and corresponding to these properties, chemical and physical, how it will be tested, those values are also there. So those are the tests on cement. And a cement, when it can be rejected, that all the standards is also there. When it is not meeting the specification drastically, then it is rejected. And how the sampling will be taken, those are also there. How the bag of cement, what should be the volume of the bag of cement, how it should be sampled out of the available bags, all these clauses are there in each of the standards pertaining to the cement for each type. So I have explained the raw materials used for the cement: calcareous, argillaceous, and silica, alumina, iron oxide, and all that. And this is the manufacturing. You can see there is a raw mill in which it is ground like a powder. then it goes to the raw mill silo, and from this silo it goes to the preheater, where some calcination happens, CO2 comes out, and then that powder material goes to the kiln, as I said. And when out of this kiln, a module type of material comes, which is called clinker, and it is stored in the clinker silo. Then for grinding further, it goes to the cement mill, and then this gypsum is added, and after coming out of the material is OPC. Here, if in the cement mill the fly ash is added, then it becomes PPC, slag, then PSC, like that. Okay, so this is the flow chart of manufacturing process of cement. And requirement of cement, as I said, fine physical property. These are the fineness, setting time, compressive strength, transverse strength, soundness. These are the test method. IS 4031, part 2, part 5, part 6, part 8, part 3. The various part of IS 4031 is available for physical property or mechanical property, both we can say. So physical properties of cement. These are the 403 series is the standard test method standard for testing of physical properties of cement. And 4032 is the test method standard for testing of chemical properties of cement in terms of LSF, insoluble residue, magnesia, sulfate content, loss on ignition, chloride content, alumina, iron oxide, etc. Okay, so, and this is the specification standard. Those are the test standard. This is the specification standard for OPC, IS 269. Those values are mentioned. One can see it in this standard. Open it out and see. Then IS 1489 for PPC, IS 1489 for PPC, which is calcined clay based, and earlier part 1 was fly ash based cement, which is mostly available in India. Then Portland slag cement, IS 455, white Portland cement, IS 8042, and machinery cement, IS 3466. It is rarely manufactured. It is manufactured by the cement plants on demand. Then sulfate resisting Portland cement, IS 12330, high alumina cement for structural use, IS 6452, super sulfated cement, IS 6909, rapid hardening Portland cement, IS 8041, high alumina refractory cement, IS 15895, hydrophobic Portland cement, IS 8043. So all these are the specification standard of cement of various types. Okay. Again, list is low heat Portland cement, IS 12600, oil well cement, IS 8229, composite cement, IS 16415, microfine ordinary Portland cement, IS 16993, Portland calcined clay limestone cement, IS 818189. So all these are the specification of cement. And rejection of cement, as I said, cement is supplied in bulk storage and bulk bed, but when non-compliance with relevant standards, then it can be rejected. Okay, and if it is more than 3 months, then it should be tested again, and if it is not meeting the criteria, it must be rejected. So these are the rejection criteria which is mentioned in the specification standard. Okay, and delivery of cement, generally 50 kg bag, but sometimes in 25 kg, 10 kg, 5 kg, 2 kg, 1 kg are also in standard. But it happens in case of white cement, but generally not in case of gray cement. Okay, printing of the type of cement, if it is a black color, you can see it is in case of OPC and white cement. The in case of PPC, the writing should be in red color. This is very, very important to recognize from the distance. And in the orange color, when it is in PSC, you can see the bags and the writing color on the bags. So one can recognize which kind of cement, which type of cement is in the bag right from the distance. You will not have to see which kind of cement. Okay. So, and the bag should have on each bag week, month, and year of packaging based before date. Okay. So this should be there. So one can easily recognize when this cement has been manufactured and which type of cement it is. So one can recognize from the bag. Okay. So now coming to the second material of concrete, aggregate. And aggregate is of two types. We can see coarse aggregate and fine aggregate based on the size, but based on the from where it is coming, aggregate can be from natural sources and aggregate can be from industrial byproducts or C&D waste or some industrial process, of course. So natural aggregates and other than natural aggregates. So we have classified in the coming standards of aggregate. We are revising the standards on aggregate, and we have defined the type of aggregate based on the sources, the natural aggregate and aggregate from other than natural sources. Okay. And lightweight aggregate is altogether a different category, which is light in nature. And waste-based aggregate is not a criteria. Waste-based aggregate is not the right word here. We can call it the industrial byproducts from where we can. C&D waste now is not a waste. It is a resource material. When we are processing the C&D waste, those aggregates are being called C&D waste-based aggregate, RCA and RMA, like that. So IS 383, presently IS 383 2016 defines the coarse and fine aggregate both, and this covers all the properties. But for your information, IS 383 is being revised, and IS 383 is being revised. It will be available in 3-4 months. It is in last stage of revision. I am the convener for that revision. So IS 383 part 1, the coarse and fine aggregate for concrete, and that this standard covers physical property, mechanical properties, durability properties, and chemical properties, which I have already explained how the standards and specifications are mentioned in any specification. And IS 383 part 2 is the fine aggregate for masonry work and plaster. And the test method presently, this was made in 1963, part 1 to part 8. But when the standards is being revised, then test method is also being revised. Part 1 all covers physical property, part 2 covers mechanical property, part 3 is covering chemical property, part 4 is covering durability property, and part 5 is petrographic examination of aggregate. So we are also revising the test method, which will be available in 3-4 months, all those standards, and how the aggregates to be sampled for the testing and sending it to the laboratory. That standard is called sampling method, IS 2430. That is also being revised. So in 3-4 months, the new standard, so aggregate system will be available. Okay. So other standards like aggregate impact value on soft coarse aggregate, this test method is being integrated in the 2386 right now. And the specification for coarse aggregate for water-bound macadam, this is a special test. It is separately, it has a specification and method of determination of stripping value of road aggregates. So this third one is applicable for bituminous material. It's not actually concrete, bituminous concrete we can say, but this test method is applicable for bituminous concrete, not for hydraulic cement based concrete, but this standard is available. So right now, this is the percentage. You can see coarse aggregate and fine aggregate, particularly aggregate other than natural sources. Okay. So this is the percentage in case of plain concrete, reinforced concrete, and lean concrete. But a new table with new percentage will be available in 3-4 months when the new IS 383 will be coming. Okay. Now, concrete mix proportioning. So the aggregate is there, then cement is there. We have discussed. Then chemical admixture. Chemical admixture, for your knowledge, there is a standard how to evaluate the chemical admixture, and that is IS 9103. 9103 is also under revision, and that will be right now it is available in one part. After revision, but revision has just started. It will be revised and will come in the 7 part 1, 2, 3, 4, 5, 6, 7, and it will cover right from the super plasticizer to air entraining agent to accelerator retarder, set retarder. Then we can call it shrinkage reducing agent, then corrosion inhibitor, then permeability reducer. So all these type of uh, chemical admixtures, we will have a specification, test method, and evaluation process, how it should be evaluated. So that chemical admixture also, cement, aggregate combined together, we are going to make concrete. So how to mix proportion, how to decide the mix proportioning, how to manufacture the concrete, what are the tests on fresh concrete property, what are the tests on hardened concrete property, and how concrete products are made. So this is the thing. IS 10262 is the method for concrete mix proportioning. IS 10262 2019. Okay, and it covers for the test mix design procedure: ordinary grade, standard grade, high strength grade, self compacting concrete, mass concrete, all this. So how the water cement ratio will be decided, how the first target test strength calculation, then according to the target test strength, how to select the materials, then water cement ratio, then calculation of water, then calculation of cement, then uh, uh, calculation of volume of aggregate, separated in two part: coarse aggregate, fine aggregate, multiplying by a specific gravity, coming to the quantity of fine aggregate, quantity of coarse aggregate, then calculation of all those components, then casting the cube, then looking at it whether it is meeting the requirements. So all these procedure is mentioned in IS 10262 for all this type of concrete, and based on that, this is a guideline. This is neither the specification. IS 10262 is neither the specification nor the test method. It's a guideline for concrete mix proportioning. It is not strictly to be followed. Means, as it is a little bit deviation will not say concrete doesn't pass or concrete fails. It is not like that. That's why it is being called guideline for concrete mix proportioning. Okay, and you must be aware of what is self-compacting concrete, what is mass concrete. So there are some differences. You must know, be aware about it. And this is the first page of this, and you can see which data should be available for going ahead for concrete mix design from A to Q. All these data should be available: exposure condition, and maximum cement content, method of placing, transportation time, what is the maximum size of aggregate, which type of cement is to be used, what is the grade of concrete, what is the method of placing, what is the degree of site control, type of coarse aggregate. So all these data should be available. Taking together, we design the mix proportion. Okay, so this is the steps you can go through. I have already explained: selection of water cement ratio, air content, then water content and admixture content, then cement and cementitious material, coarse aggregate proportion, then different coarse aggregate fraction, then estimation of fine and coarse, then trial mixage. Illustrative examples are also mentioned at the end of the standard, okay, guidelines. So following this, one can design the concrete mix proportion. And high strength grade, a little bit how to select the materials, and the procedure is almost same with a little bit difference in the values, how to select. Okay, and this is a self-compacting concrete. So features are passing ability, which is tested as per AL box. There is a standard available in IS 199. Okay, and filling ability, segregation resistance, and viscosity. So this is the four property available in the fresh concrete state for any self-compacting concrete. And according to this, when a self-compacting concrete is made, the trial is made after calculation and following the 10262, then these tests are done in the fresh state. When these are not meeting the specifications fixed by the user, then there should be adjustment in the concrete mix proportion like this. And how the mix proportioning should be done, approach has been written in 13 steps. Okay, and one can follow. And but the premises of is that the fine content should be in the range of 4 to 600 kg per meter cube of concrete. And what is the fine content here, or powder content? The materials finer than 0.125 mm. Okay, and water content should be 150 to 210 for self compacting concrete to be designed. And it is essentially to use high range water reducing admixture when you are designing the self compacting concrete. But anyone will design, then only will understand a little bit tricks and art of designing the self compacting concrete. And the mass concrete, again the procedure are almost same. And but one thing is different in mass concrete. When the maximum size of aggregate is 80 mm or 150 mm, then for target strength calculation, FCK plus 1.65 into a standard deviation, whatever will be coming, it will be multiplied by 20%. So, or 1.2 factor, or in case of 150 mm, 1.25, to achieve the concrete mixage which is sieved on 40 mm side, because we cannot cast the cube of 80 mm and 150 mm maximum size of aggregate, and testing facility will also be not available. So that cubes are cast after mixing, cubes are cast after removing the 40 mm plus aggregate from the concrete mix. Okay, this is the difference. Other things are almost same, but one will design, only then will understand what is the difference in mass concrete. One more restriction is there should be sufficient mortar content when 80 mm plus maximum size aggregate or 150 mm plus maximum size aggregate is designed. And especially these type of concrete are used in dam construction. Mass concrete is also used in the high thickness foundation, like if a foundation of 100-story building is having 2-meter thickness or 1.5-meter thickness, that can be called mass concrete, and that becomes a tricky because of the temperature generation in the core of concrete. And how to control the temperature, all these tricks and all these arts, all these standards is available. One will have to study the mass concrete in detail. So manufacturing process is, and using means the not only manufacturing means the steps of concrete to be manufactured and used. The first is batching, that should be preferably in wave batching, then mixing in the mixer, then transporting it to the site and placing it, then compaction of the concrete to remove the entrapped air void, and then after hardening, a little bit hardening, curing throughout, and then finishing. So when hardening starts, curing starts. Okay, and then finishing comes after compaction, then curing. Finishing is not at a proper place here in this slide. Okay, compaction, finishing, then curing. Okay. So ready mix concrete, we have a standard IS 4926, but ready mix concrete is nothing, a concrete produced in the batching plant. If I am selling the concrete, I have a batching plant, but I don't have a project, I am selling the concrete for individual house builder or any project or anything, then that plant is called a ready mix plant. And if I have my own project, and for my own project I have a batching plant, then it is called a batching plant. Okay. So how the concrete is manufactured, a little bit other terms, how the proactive control and all those things, those are mentioned in this standards. So one can go through it in the IS 4926. So this is the specifically ready mix concrete standards, or this is not a specification standard. Again, this is a code of practice. You see, ready mix concrete, code of practice. It is not a specification standard. As I said, specifications are of three almost: specification, test method, and code of practice or guidelines. Okay. So this is the right now fresh concrete, how to test the fresh concrete for various properties, because fresh concrete properties are very, very important. So sampling, then consistency of fresh concrete, density of fresh concrete, air content, then making and curing of test specimen, then self-compacting concrete, fresh concrete property, as I said, passing ability, segregation resistance, all those properties we have in part 6. Then part 7, setting time of concrete by penetration resistance. In part 8, water soluble and acid soluble chloride. This standard is under development. I am the convener for this also, IS 1199. So we are working on this. And then analysis of freshly mixed concrete. This is also under development. Okay. So these standards, one will have to see that to test the fresh concrete property. And how it looks like, one can see the part 1, then part 2, one should go through it. Then these are this is slump, how the slump is measured, when it is called true slump, shear slump, and collapse. So one can see, and one should relate these figures when you are testing in the laboratory or at site. Okay. So this is a BB consistometer. When the concrete doesn't have a flowable property, dry, almost dry in nature, so slump test is not valid test. So we test it on BB consistometer test. And this is a compaction factor test. Normally these tests is not being used nowadays. This is concrete in container. This is before compaction and after compaction. This is for bleeding test. This is flow table test. This is we call it flow on the table. In case of self-compacting concrete, determination of density, then how determine density. These are the formulas on which determination of air content, and there is 2 methods mentioned, pressure gauge methods and water column methods. You can see the equipment. Then making and curing of test specimen, part 5, how the cube specimen are made, how the cylinder specimens are made, how the curings are done for the specimens. These are very, very important while making any concrete structure. Then test on fresh self-compacting concrete, various tests, then setting time of concrete, penetration resistance, and then test of hardened concrete. So these are the set of tests. One is testing of a strength of hardened concrete, and these tests are compressive strength, flexural strength, and split tensile strength. Then other property like density of hardened concrete, then depth of water penetration test, initial surface absorption test. This is one of the durability indicator. Earlier one, the water penetration test, is also a durability indicator. Oxygen permeability index, This is also a durability indicator test. Then determination of carbonation resistance. Carbonation is one of the problem of concrete from durability point of view. Okay, so carbonation resistance test. Then part 3 explains how the making, curing, and determining compressive strength of accelerated cured concrete test. So when we want a prediction of 28 days strength early, within 2-3 days, so we have an accelerated test, and there is a method. This is under development right now. This standard is available for OPC only, and it is very, very old. So we are going to revise it. So this is also under development. I am also the convener for IS 516. So we are doing it in the committee. And how to sample, prepare, and testing of concrete cores. This is also available. And various non-destructive testing for evaluation of concrete structures. We have UPV, means part 5, section 1, ultrasonic pulse velocity testing, in which velocity criteria is given for different type of aggregate, when different type of concrete, when the concrete is to be called excellent or good or poor. Okay, and then half cell potential. This is a test for concrete structure, particularly aged concrete structure, when some doubt is there that reinforcement inside the concrete is going through the corrosion, and then the chances of corrosion we can predict by doing this test, half cell potential test. And then up to what depth the carbonation has happened, that can be measured, and this test is called carbonation depth test. And rebound hammer test is based on the rebound from the concrete surface, and to some extent it can be related to the strength of concrete, but it should be interpreted along with the UPV and the core test. So this rebound hammer test, how to do, how to make a grid, and how to interpret the results. So all these tests, a series of IS 516 is available, a standard is available. Okay, and this is a hardened concrete method of test. One is a drying shrinkage and moisture movement. We have, but other test. Second one is creep of concrete. Creep is an important property. This is also under development. We have a standard on how to determine modulus of elasticity, and we have a static modulus of elasticity. So, but section 2 is under development. Determination of wear resistance, this is also under development. This determination of bond in reinforced concrete, bond of reinforcing bar, which is a very, very important property. This is also under development. And determination of Portland cement content. This is an ambiguous issue whether we will be developing it or not, but this is also under development. And determination of water soluble and acid soluble chloride in hardened concrete. A standard is available, but this is also under development because that is not being used properly. Okay, so this is the set of IS 51 series. So how these tests are looks like, this is the, I have explained. So this is the first page of each one. So one can go through these standards, test method. And concrete is mostly used residential, dam, reservoir, bridges, foundation, high-rise buildings, rigid pavement, RCC paving block, concrete sandwich panels, etc. Okay, but concrete is concrete. It can be, it can have a difference in fresh concrete property. It can have a difference in hardened concrete property. Hardened concrete property means a strength and a strength-related property. What is a strength? You know, clear strength, and a strength-related property means the creep, the elastic modulus, Poisson's ratio, drying shrinkage, all those things. And what is the durability property? All those things may differ, but concrete is used in all these applications. Application of concrete, dam. Now come to the other part. Concrete is over. If anyone will have a questions, one can ask. It is 5 o'clock going to be. I will have to complete in half an hour. So lime and gypsum. This is also the raw material for producing different products. And we have a set of specification, and it has a separate committee. till the time whatever I have discussed, that comes under CD2. This lime and gypsum comes under the difference committee, and these had standards in case of a specification for building lime and this byproduct of gypsum for construction. So we have a separate standard for that. And gypsum board you might have seen, and gypsum is also used in cement making, as I have explained. So we have standards for all those things. These are the testing methods separately, because the lime and gypsum will have to be tested separately in a little bit different way. So we have a set of tests, just like for cement we have 4031 and 4032. Okay, so one can see this up to part 1 to part 11 we have the test method. Okay, and separately we have IS 2542 part 1 section 1 to section 14. So we have here series of gypsum plaster, concrete and products. So method of test, plaster and concrete. Okay, and then other 4 standards: 4098 for specification of lime pozzolana mixture, 3115 for lime based blocks, 4139 calcium silicate bricks, and 15642 pulverized fuel for lime pozzolana mixture application. So these are the specification standard, not test method standard. And other part is IS 2095 part 1, part 2, part 3 plain gypsum plaster board, coated laminated gypsum plaster board, and reinforced gypsum plaster board. So this committee also have product in it. So these are the product and these are the specification of the products. And IS 8272 a specification for gypsum plaster for use in the manufacture of fibrous plaster. So if we add fiber, those 3 are without fiber, this is the with fiber, and it becomes a fibrous plaster. Okay, and now comes to the bricks and blocks. So what is the raw material, manufacture, dimension, physical test, chemical test, and there are variety of bricks, and we have a specification for all of them, and variety of blocks. So concrete blocks also. So this is another CD, civil engineering committee, civil engineering division. And these are the bricks: 1077 common clay bricks, which we usually see. Then burnt clay hollow bricks. There is a hollow space inside the brick. And then a specification for sewer bricks, a specification for burnt clay soling bricks. Then another with burnt clay fly ash building bricks specification. Then IS 12894 pulverized fuel ash lime bricks, 16720 fuel ash cement bricks, and 1725 stabilized soil blocks used in general building construction. So these are all the specification standard. Okay, and there are test method mentioned, particularly which test is to be done nearby the specification itself, and we have it wherever a separate standard is available, a separate test method is there. But if separate test method is not available, in the appendix of every one there are test methods is attached. So a specification and some test method also. Now IS 3495 part 1 to 6 burnt clay building bricks method of test. As I said, these test methods are available separately from part 1 to part 6 for various property: compressive strength, water absorption, efflorescence, rappage, initial rate of absorption, and modulus of rupture. So these are the tests on burnt clay bricks. We have a set of a standard and for test method, and value is in the specification standard. Then tile, we have a different type of tiles. It can be ceramic tiles, it can be porcelain tiles, mosaic tiles, etc. And one can be glazed, it can be non-glazing. So variety of tiles is available, and specification standards are there, and similarly test method standards are there, and one can follow for particular type of tiles. So you can see there is a standard for roofing slate tiles. Another is 2690 burnt clay flat terracing tiles, 2690 burnt clay flat terracing tiles, part 2 handmade, and IS 3951 hollow clay tiles for floors and roofs. IS 3367, this is burnt clay tile for use in lining, irrigation and drainage works. IS 13317, clay roofing country tiles, half round and flat tiles. So these are the specification standards for these type of tiles. And not only the tiles standard, there should be 2-3 slides more on tiles. There are test methods and there are glazed tiles, ceramic tiles also. So that this is not exclusively being covered, one can go through it. Okay. And steel can be reinforcing steel for concrete. Steel is used in pre-stressing. So pre-stressing steel, there are method of testing, as I said, and third use of steel is in structural steel directly, and then how it is manufactured and what are those mechanical properties are. So we have CD 54 dealing with steel. So there is a separate committee, separate civil engineering division, means CD, civil engineering division, CD 54, which works on the formulation of standardization for steel, for all the three: reinforcing steel, pre-stressing steel, and structural steel. Okay, and test method also. Now, recently we have formulated a standard for glass fiber reinforced polymer bars that also comes under this. So that is not steel, but that also comes under CD 54. So reinforcing steel, it can be mild steel, it can be HYSD bar. Okay, and how it looks like. So part IS 4432 part 1, IS 43 part 2, and IS 1566 1982. All these are under revision. All these are under revision. Okay. Most important is generally comes across to us while construction is being taking place, particularly reinforced concrete, IS 1786 2008. So this standard is available, but this is also under revision. Very shortly, a new standard will be there, and which will not be clumsy. I am the part of as a member in this. So in a simple form, this standard is being revised, and soon it will be available for use. Okay, but this is very, very important. Now, 13620 fusion bonded epoxy coated reinforcing bar, method of joining steel, welding. So there is a standard IS 9417, and mechanical couplers. Another way of combining the two reinforcement is one is welding, second one is coupler, using the coupler. So for coupler, recently we have brought a standard IS 16172. We have brought this standard in 2023. Okay. And then pre-stressing steel, we have IS 1785 part 1, part 2, then IS 2090, IS 6003, 6006, 16644, and 14262. For various usage, one can go through it because a little bit difference are there in each of them. Okay. And then method of testing. It is a very, very important. IS 10790. This is the method of sampling of steel for pre-stressed and reinforced concrete. Part 1 is for pre-stressing steel and part 2 is for reinforcing steel. So 10790. And the series of IS 1608, the metallic material tensile testing, particularly this is tensile testing. Part 1 deals with the method of test at room temperature. Part 2 deals with method of test at elevated temperature. And part 3 deals with the method of test at low temperature. So what do you mean by tensile testing? Means ultimate strength, tensile strength, ultimate strength, yield strength, and elongation. So all these elongation at peak stress, all these parameters are available while adopting this test method IS 1608. Okay. Now coming to the structural steel, this is the two specification. IS 811 specification for cold formed structural steels, various type of sections, and another one is IS 2062 hot rolled medium and high tensile structural steels in a various forms like channel, angle, all those things. So these are the standards for structural steel. And what is the design code? IS 800. Now, now coming to the special publications for steel, part 4, SP6 part 4, use of high strength friction grip bolt, part 5, cold form light gauge steel structures, and part 6, application of plastic theory in design of steel structures. Okay, just a minute. Now, other, as I said, IS 432 part 2 and IS 1786, there is a comparison, but first and second is also under revision. IS 1786 is also under revision. So let us not compare it right now. Revision comes. 1786 will come very soon. Wires, we have a standard IS 6003, and strands, there is a difference between wires and strands. Strands are pre-stressing strands, and one bar can be called bar, and strands can be a set of set of wires. Okay. Timber, we can deal with classification, seasoning, properties, defects, preservation, method of testing, and timber products. I am not so expert in this area, but in any case, we can make the furnitures, light packing cases, heavy packing cases, agricultural implementation, and ternary articles and toys, veneers and plywoods. Veneer and plywoods are frequently we are using in our home. And plywoods are also used for shuttering purposes, like that. So we have a use of timber for different purposes. And seasoning, we have a standard for seasoning 1141 1993. What is seasoning? Seasoning is when raw wood is taken from the tree, then it will have to be seasoned so that immediately it should not be used. If it will be used, it will not be the same while being in service. So any timber should be seasoned properly, and type of timber and seasoning process has been given in IS 1141. Okay. Then preservation of timber. How to preserve those timber? IS 401 standard is available. We have IS 401 preservation of timber, IS 10013 specification for water soluble type wood preservatives. So there are preservatives to be used, and one is part 1 acid copper chrome, part 2 copper chrome arsenic, and part 3 copper chrome boron. And IS 10753 is used for as a code of practice for preservation of wooden sleepers for railway track. Earlier wooden sleepers were used, but right now we are not using wooden sleeper. So it is almost, this standard is not being used right now because we are not using right now wooden sleepers. Okay. IS 9096 preservation of bamboo for structural purposes. This use of this structure, now bamboo is being used in a different usage. So use of bamboo has increased. A government has given thrust looking at its production in Northeast. So this use of this standard has increased. And we have another standards for testing of preservatives. IS 4833, 4873, 2753, part 1, part 2, all these standards are available. Timber panels, IS 190, IS 883, IS 1003, IS 1326, IS 2674, IS 7344, and a specification for wooden sleepers 10394. And again, I am not reading the names. These timber panel products are have different bamboo mat veneer, bamboo mat board, timber door, BWP grade bamboo. All these standards are available. Okay, and plus door shutters are being used, and there are test method also. Wooden flush door shutter, HDF panel door, all these standards are available. Now coming to the stones, so this comes under different civil engineering division, CD6 perhaps. So there are series of specification standard limestones for marble, for structural granite, for laterite stone block, for sandstone, for coarse aggregate, for water-bound macadam, as I said. This is the test method we discussed earlier also. And stone lintels. Earlier, lintels were made, stones were used, and polished building stone, part 1 granite. So polished building stone and polishability and shining capability is also measured. So part 1, and this how to test the compressive strength of a stone, transverse strength, tensile strength, shear strength, true space. All these are test method standard. True specific gravity, water absorption, weathering, durability, abrasion resistance, water transmission rate, surface softening. All these all these parameters are important. If you will see the specification standard for different type of stone, different values are there. How they will be determined? These are the test method standards. Then permeability, toughness, aggregate impact value, and stripping value of road aggregates. This test method we have discussed. It is for bituminous concrete. Okay. Then glass. We have glass. Glass is a very glass is a material which looks like the same, but it has a different use. Glass can be used in the buildings for general purposes, general methodology for selection. Glass can be energy and light, can be transmitting and all those. So this has a different IS 16231. Then fire and loading point of view, and then safety related to human. So all these part 1, part 2, part 3, part 4 are important. I'm not the expert of this area. So, but from thermal comfort point of view, from fire rating point of view, when it is being used in buildings, from safety point of view, all those criteria, the specifications are mentioned, and there are test method also. So there should be some more slides about the test method and all that, but one can go through it. The National Building Code, which is just about to come in 2-3 months, we are working on it. So this has specifications mentioned in detail. And now coming to the innovative materials. Innovative materials is nowadays geosynthetics, use of geosynthetics and geotextiles are getting popular in every type of construction. Particularly, you can see there are different type of geosynthetics are available. It can be one dimensional, it can be two dimensional, it can be three dimensional. uh, One dimensional geosynthetics are geostraps and geocables, we call it. Two dimensional like geotextiles or geogrid, geocomposites, geomembrane. But different type of geotextile, geogrid, geocomposite, geomembrane have a different usage. Three-dimensional geosynthetics are like geomat or geocell, geonet, geomatrices, geospacer, 3D geogrid. All these are being used for different purposes. in geotechnical engineering, these are having a lot of use, and from there this word geo has come. So IS 17369, this is geotextile and geotextile related products, and this is a strength of internal structural junctions. So this is a specification standard, part 1 and part 2. Part 1 is for geocomposites and part 2 for geocells, as I said. And 14716 geosynthetic, this is the test method. So test method for determination of mass per unit area. So one parameter is, and I forget to mention, these are the 4-5 parameters. One is physical property. Physical property means what is the mass per unit area, and what is the specific gravity, and these two property is physical property. Then mechanical property, sometimes in mechanical property tensile strength, sometimes tear strength, and these are the test method. Puncture strength, all those strength properties, mechanical properties. Sometimes the geotextile are used in the pavement, and hydraulic properties are important. So hydraulic property, and it should be durable, so durability property. So in general, 4-5 types of property, I mean to say, is very, very important, and based on that specifications are there, and based on that there are test methods also. And we have to work more at a BIS level in making standards for each type of geosynthetics. These are the materials every day evolving. Okay, so IS 14716 geosynthetics test method for determination of mass per unit area of geotextile and geotextile related product. As I said, there are so many products. And 14714 geotextiles determination of abrasion resistance. 14706 geotextile for sampling and preparation of test specimen, how to take the samples. And then 14293 method of test for trapezoidal tearing strength, as I mean to say, it is one of the mechanical property, trapezoidal tearing strength. And 14715 jute textile strengthening of subgrade in roads specification, this is a specification standard. And part 2 control of bank erosion in rivers and waterways, this is also a specification. So these specifications are in terms of physical property, mechanical property, as I mean to say, tear strength, mechanical and tensile strength, or in terms of strength related properties. And this 14986 guidelines for application of jute textiles for rainwater erosion control in road and railway embankment and hill slopes. And 15869 textile open weave wire Buastra specification, first revision. Then geosynthetics for highway specification. So in highway, we have a lot of specification, and geosynthetics means all type I have explained: 1-dimensional, 2-dimensional, 3-dimensional, and different types. And then geosynthetics, geotextile used as a protection of cushioning material, IS 16090. Then 16352 geosynthetics, high density polyethylene HDPE geomembranes for lining specification. Then geosynthetics as a geotextile used in subgrade stabilization in pavement structure. Geosynthetics, geotextile used in subgrade separation in pavement structure. Sometimes it is used as a separator, sometimes used as a drainage layer. There drainage is allowed where we want to separate these geomembranes are used. So it is based on the application. Then it is called geosynthetics, geotextile for permanent erosion control in hard armor system. Then geosynthetics, geotextile used in subsurface drainage application, as I say. And then geosynthetics, needle punched non-woven geobags for coastal and waterways protection. So these are difference. There are difference in terms of specification and their values, and they are determined commonly from same type of test, and the values is compared as per the application specification is required, and then we can say the conformity hai ki nahi hai according to the values of those tests. Another specifications are geosynthetics, polypropylene, multi-filament woven geobags for coastal and waterway protection. Another is geosynthetics, geogrids for flexible pavement specification. Geosynthetics, polymeric strip, geostrip used as a soil reinforcement in retaining structure when shear strength of soil is low. This is used. Then geosynthetics, geogrids used in reinforced soil retaining structures. Geosynthetics reinforced HDPE membrane for effluent and chemical resistance lining specification. So all these geosynthetics are used. Geosynthetics as a geocells specification, then load bearing application and slope erosion specification. So it has a two application, and there are different specification for these two application. Then 17880 geosynthetics polymer gabions for coastal and waterway protection. Then 18309 geosynthetics for prefabricated vertical drain for quick consolidation for very soft plastic soil. So all these are about geosynthetics. And then geosynthetics can be natural geosynthetic, can be polymer based geosynthetics, okay, like polypropylene, HDPE, etc. And IS 15643 2000 non-destructive examination of polymer based composite materials, you can see, okay. And then fiber reinforced composite IS 14862 fiber cement flat sheets, we have a specification IS 14871 2000 products in fiber reinforced cement, IS 17161 flexural strength and toughness parameter for fiber reinforced concrete. This is the method of test. And we have a National Building Code, volume 1 and 2 of NBC 2016, has 13 parts, but right now we have perhaps 16 parts or like so. I don't remember right now. So it has a more part right now, but some parts have been added this time when it is being revised. So these are the structure of the earlier means which is existing National Building Code, but it will change. Of course, new National Building Code is coming up. So I'm not going through all these details. One can read it out on their own. Okay, these are the various parts from part 0 to part 12, and for the new and alternative building materials and technology, following parameters shall be taken into account. This structural stability, durability, acoustics, all these things are coming, is available in the National Building Code. Sustainability has become very, very, there is a separate chapter was available in the existing National Building Code also, but this time it is coming in a broader way and a more explicitly explained and able to be applied in a real life situation. So this is the barcode one can use to see the different parts of National Building Code, how it looks like. Okay. So these are the links available, and these are the other series of booklet available for from BIS, Guide for Homeowners, Guide for Homeowners Series 2, Guide for Homeowners Series 3. All these booklet and leaflets are available from Bureau of Indian Standards for individual house builders. So I think I have come to the end of this. So thank you very much. I have gone through very, very fast. I could have gone into the details of particularly in my subject area, which is of my interest, but due to the paucity of time, this much would have been able to be done. Thank you very much from my side. So any questions, we can take it up quickly in 4 or 5 minutes. And so that I have been instructed that I will have to uh, uh, complete
Yes, sir.
5:30. So thank you very much.
Yeah, sir. Thank you very much. It was a very well structured presentation given by you, and I'm sure that it must have been very quite fruitful for all the participants. And if there are any queries regarding the same, you can communicate us to ced46 at the rate bis.gov.in or ced at the rate bis.gov.in. And any other, I'm not able to, currently there's no query regarding that. So I think we are good on that. And with this note, thank you very much, sir, for your guidance. And I will also thank all the participants and the students. And we will be meeting next Friday uh, with our third lecture on this series. So thank you, sir. Thank you.
Okay, thank you very much. And you can share my number to them. If they have
Sure,
any
sir.
query, they can contact me directly or they can
So
write to you. Okay.
we will share the presentation as well as your contact details. Okay. Thank you, sir.
Okay. Thank you very much. Thank you very much.
हो गया ना